This call is now being recorded.
Okay, so good afternoon all. So in the last lecture, we have started with the next type of the recording techniques, that is diagrams. So whatever the limitations are there in the charts, in the all the types of charts, that limitations we can eliminate in case of a diagrams. Maybe any type of diagram. It may be the flow diagram and it may be the string diagram. Okay, so what is the major limitation of that particular charts? So that chart, it will give only overall picture and it will give the sequence of operation. But during the operation process, whatever the backtracking is taking place, or whatever the path of the movement is there, for example, whether your product is moving in vertical direction or horizontal direction, or whether it is moving in the inclined direction, so that movement we have to identify in the organization. But that will not be tracked by using that particular operation process charts or the flow process charts or the multiple activity charts. So in order to avoid the such types of the limitations, the second recording technique is developed, which is called as a diagram. So that particular diagrams, it is having the main advantage is that it will give the path of the movement. That means in which direction whether your product is moving. In addition to that, also it helps to get the information related to the backtracking. Backtracking means if the product is moving from workstation to 1 to 2, 2 to 3, 3 to 4, but from 4, if again it is coming back to the workstation number 1 and 2, that means the backtracking is taking place. That means repetitive movements are taking place from workstation 1 to 4 or 4 to 1, 1 to 4, 4 to 1, like that. Repetitive movements are taking place, and such types of the movements can be recorded by using this particular diagrams. Also, it helps in order to it helps for the designing of the layout. We have discussed their major three objectives. That is, these diagrams are also helpful for designing of the before starting your organization. If we will apply this concept of the diagrams while designing the layout, at that time also it plays very important role. In addition to that, whatever the traffics are taking place during the operations or during converting the raw material into the finished goods. That means once the one operation is finished, then and then only your raw material has to move to the next machines or the next operation. So if any traffic is there in between workstation 1 and workstation number 2, that traffic can be also eliminated through this particular diagrams. Also, it helps to identify the backtrackings and the obstacles during the operation. Whatever the disturbances are observed in that particular operation, that can be identified by using this particular diagrams. And in that, we have discussed with the type number 1, that is flow diagram. So why this particular flow diagrams are implemented as the recording techniques? So from that particular figure only, you will get the idea what is the movement of the path, or what is the path movement of the raw material or the observer or the operator. So this particular flow diagram, it will be applicable to both operator as well as it is applicable for the product also, because once your raw material is start manufacturing, or it will start to convert the raw material into the finished goods, so what will be its movement? So from point A, for example, from this particular point A, how it is moving to the point B, so that particular direction it can be indicated by that particular inclined line, and along with at the center there is a arrow is provided. So this particular center arrow, it indicates the direction of the flow. Then from B it is moving to the C, from C it is moving to the D, from D it is moving to the E. So like that, whatever the movements are taking place by that particular raw material or the operator, that movements can be recorded by using this particular flow diagram. But this flow diagram is having again one limitation, that is whatever the complex operations are there, or whatever the complex repetitive movements are taking place, or the complex backtrackings are taking place, that complex processes cannot be represented by using this particular flow diagram. So in order to avoid that particular limitations, the next method is developed, which is called as a string diagram. So the construction of the string diagram and the flow diagram are somewhat similar to the each other, but whatever the limitations are there for this particular flow diagram, that limitations can be eliminated. So the primary function of the string diagram is to produce a record of existing set conditions. So whatever this particular record string diagram is there, that string diagram we are going to apply for the existing layouts only. Existing layouts means already the layout is designed, already that layout we are using for the production purpose, but in that particular layout we don't have any idea related to the how much distance the material has to travel from one station to the another station, or how much distance that operator has to travel from one machine to the second, second to third, third to fourth. So in such condition, if I have to calculate the distance traveled by the material from one location to the another location, or distance traveled by the operator from one machine to the another machine, that distances in complex condition, it can be recorded by using this particular string diagram. So that particular string diagram we are going to apply for the existing layout which is already designed, which is already implemented in the industry for the production purpose. Okay, so this particular method, it is very effective. This method is very effective as compared to the flow diagram, because whatever the complex backtrackings are taking place, that means in some of the operations, sometimes the maximum times the backtrackings are taking place, or maximum times there are disturbances arises, but such types of the complex backtrackings, complex processes, it cannot be recorded by using the flow diagram. So such types of the complex processes can be recorded by using this particular string diagram. So the name itself suggests that string means, in Marathi you can call it as a dora. The string is called as a dora. So by using that particular string, we can measure the distance traveled by the operator, or the distance traveled by the material from one machine to the another machine. So how this particular method is implemented in the industry? So first of all, let us assume that whatever the layout is already designed and whatever the layout is already implemented in the industry for the production purpose, and let us assume a one distance, one sample distance, or you have to assume that particular distance in that particular layout. Let us assume that your material or your operator has to travel the 500-meter distance. Means if your raw material is converted into the finished goods, from that particular starting point to the end point, if your material has to travel the 500-meter distance, but again I have to check it whether it is 500, or whether it is more than 500, or whether it is less than 500, because in between that particular 500, some backtrackings are also taking place, some disturbances are also taking place. Such types of the distances, such types of the complex processes cannot be recorded by using the flow diagram. Therefore, if I have to implement this particular string diagram concept in the industry, so what I have to do, let us assume that initially that operator or that particular material has to travel the 500-meter distance from start point to the end point. But once again, I have to measure it. So what I have to do? So I have to take a one smart board, or I have to take a one soft board. Maybe the board available in the form of wood, or it may be available with the help of a thermocol. So on that particular thermocol, we have to draw our layout, or on that particular whiteboard, whatever you have taken on that particular whiteboard, you have to draw the layout of your organization. In addition to that, you have to indicate, the all the important departments or all the important machines, machine number one, machine number two, then this is the department, this is the another locations. So all the important things we have to represent on that particular layout or on that particular blackboard. Then to the each and every location we have to fix the pin. For example, machine number one pin, you know about the pin which is used on the notice boards. So if we have to attach even a notice on the notice board, so we are using the some of the standard pins. So by using that particular pins, we can attach that particular paper to that particular notice board. So such types of the pins also used in this particular string diagram. So on that particular board, what we have to do, we have to attach the pin for the machine number one, separate pin, for machine number two, second pin, for another machine, third pin. So wherever the locations are taking place, at that particular respective locations, we have to attach that particular pins. So in this particular figures also you can see, let us assume that this is your board. For example, this particular rectangle, it represents your board. It may be your whiteboard. Okay, now this is your workstation number one. So here I have to locate one pin. So this particular circle, this particular small circle represents the one pin. Then this is the second circle which is located at point B. So this is the second circle, means it represents the second pin. So whatever the number of circles, small circles are represented on this particular diagram or on this particular paper, it represents the pin attached to the each and every machine. Okay, once your a board paper is ready, on that particular board papers, if I have attached the pin for the respective location or for the respective department location, then I will take the string in the sense Dora. You can call it as a Marathi as a Dora. So initially I will take the total length. How much amount of distance has to travel? For example, 500 meter. So what I will take initially, I will take the 500-meter string in my hand. So because one uh, we have assumed that particular distance traveled as a rough figure as a 500 meter. So 500-meter string I will take. I will start from this particular point A. So that particular string will be attached to the point number A. Then we know about the movement of the material or the movement of the worker from that particular machine 1 to or machine 2. So from this particular point A, it is moving to the point number F. That means initially from this particular point A, your material or your operator is moving from A to F. So I will take this particular string from A to F, then from F to C, from F to D, then from D to I, then from I to B, then from I to E, then from E to H, E to G. So like that, whatever the movements are taking place by that particular material, or whatever the movements are taking place by that particular operator from one location to the another location, this particular location can be traced by using that particular string according to the movements taking place in that particular operation process. Each and every movement or each and every movements can be recorded by using that particular string. So once your end point is coming, at that particular end point we have to measure the total distance traveled by that particular string. We have started from that particular point A, and if your point is finishing at point particular J, for example, this is the last point as a J. So from A to J, if your material is traveling, or from A to J, if your operator is traveling, to travel that much amount of distance, how much amount of string is required? For example, let us assume that 450 meter. We have taken the string as a 500 meter, but at the end, whatever the distance are traveled from one location to the another location, that distance has been observed that only 450 meter. That means remaining 50 meter extra string will be available. Means after the comparison of results, that means after the comparison of 500-meter string and the 450-meter string, it has been observed that 500-meter distance has to not travel by that particular material, or it has to not travel by that particular operator. He has to travel only 450-meter distance. That means that 50-meter extra distance is traveling by that particular operator, or it is to be traveled by that particular material, and that extra distance we have to track or we have to identify by using this particular string diagram. Once you got the final answer as a 450, in that at that time we have to eliminate some unnecessary processes, you have to eliminate some of the backtrackings, you have to eliminate some of the disturbances which are present from the machine 1 to 2, 2 to 3, 3 to 4, and all the factors will be eliminated, and at the end you will get the total distance traveled by that particular operator, or the total distance traveled by that particular material from point number 1 to the point number 2. So like that we are going to implement that particular string diagram in order to find the actual distance traveled by the material or the actual distance traveled by that particular operator. So if you compare the flow diagram and the string diagram, both are same for the looking, but in case of a flow diagram you will get only path. You will get only path from which to which, from this machine to this machine, this machine to this machine, but here we are unable to calculate the actual distance. In case of a flow diagram, we are unable to calculate the actual distance traveled from one machine to the second machine. In addition to that, we are unable to track some complex operations or some complex backtracking. So we are unable to get from the flow diagram. To avoid the such types of the situations, so here the string diagram plays very important role. So in that particular string diagram, we have to take some instrument in the sense we have to take one whiteboard. On that particular whiteboard we have to draw the layout. On that particular layout we have to implement the location of each and every machine as per the layout design. Then we have to use the pins. We have to use the pins which will be located to the respective machine location, and from the start we have to start that particular string. And if from point A, if your operator is moving to the point B, you have to take that particular string from A to B. Okay, from B, if your operator is moving to the machine number G, then from that particular B, I have to take that particular string towards the machine number G. From G, again it is E, then F, G. So like that, you have to take that particular string along with movement of the material and along with the movement of the operator. And from that, at the end, how much distance is traveled by that particular string, it represents your total distance traveled by that particular operator or the total distance traveled by that particular material. So whatever the 500-meter string we have taken, that all the 500-meter distance will not be traveled by that particular material. Sometimes only it is traveled up to the 450, or sometimes due to the maximum backtrackings, that operator or that particular material has to travel the more distance. For example, it maybe takes 600-meter, 700-meter, but only 500-meter strings is available with you, but that material has traveled 600-meter distance or the 700-meter distance, means he is going to travel extra 100-meter or he is going to travel extra 200 meters. That distances also can be recorded by using this particular string diagram. That means whatever the complex processes, whatever the complex backtrackings are taking place, that complex backtrackings or actual distance, it can be calculated by using this particular string diagram. Therefore, whatever the limitations are there for the flow diagram, that limitations can be eliminated by using this particular string diagram. Also, okay, so this is about the string diagram. Now, whatever the figure is in front of you, that figure represents, whatever the figure in front of you, that figure represents when whiteboard paper is there. On that particular paper, the location of each and every machine is there. Whatever the number of small circles are present near to that particular point A, then this is one more circle, then this is, whatever this particular number of circles are represented to the respective location, that number of circle represents the pin attached to that particular respective location. Why this particular pin is required? To attach your string. Why this particular pin is required? To attach your string. You can attach that particular string to that particular pin, and then we will move to the next department. In the next department, again another pin is there. You have to attach your pin at that particular location. Again, from that department, we have to move to the second department. Like that, by using that particular string, we can calculate the actual distance traveled by using the machines. But this particular string diagram is mostly important for the complex backtrackings. For example, at point A and at point G, again there is a repetitive movements are taking place from A to G, G to A, again from A to G, again from G to A. So like that, repetitive movements cannot be traced by using the flow diagram. So such types of the repetitive actions or repetitive backtrackings can be recorded by using this particular string diagram. So this is the second techniques which is used in the diagrams, and mostly as compared to the flow diagrams, this particular string diagrams are mostly used in the industry in order to find out the actual distances traveled by the material or the actual distance traveled by the operator. In addition to that, it helps to identify the repetitive backtrackings, or if any disturbances are observed from operation 1 to 2, that disturbances are also recorded by using this particular string diagram. So only you have to keep in mind, simply by using the string and by using the pin, we can calculate the actual distance traveled by the machine, or sorry, actual distance traveled by the material or the operator from number of locations. Okay, so this is about the string diagram. And in this particular diagram, only two techniques are there. One is the flow diagram and another is the string diagram. So whatever the limitations are there for that particular, all the types of charts, all that particular limitations of the charts can be eliminated by using the flow diagram and by using the string diagram. So in that particular diagrams, we are having only two types. One is the flow and another is the string. Okay. Now, the next important technique which is used for the recording purpose as a travel chart. The travel chart is also one of the recording techniques which is mostly used in the industry. So the travel chart, as just now we have discussed about the important things related to the string diagram, and it has been observed that the string diagram is very effective. The string diagram is very effective diagram which is used to calculate the actual distance traveled by that particular operator or the material. But this particular string diagram is the, or this particular diagram, it takes the longer time. This particular string diagram, it takes the longer time to obtain the correct distance traveled by the operator or the material. Means from one machine to the second machine, you have to take that particular string. From second to third, you have to take that particular string. From third to fourth, fourth to fifth, fifth to sixth. So whatever for the number of locations we are visiting, at to each and every location you have to take that particular string. Means that particular string diagram is very effective, no problem, but it is taking the longer time in order to calculate the distance traveled by the operator and the material. Also, okay, also in addition to that, whatever the longer distances are taking place, in addition to that, again, whatever the repetitive movements are taking place, whatever the backtrackings are taking place, again it becomes more and more complex. In the flow diagram, repetitive backtrackings, repetitive movements cannot be indicated. It can be eliminated in the string diagram. Again, in the string diagram, again the number of complex processes are increases. Again, number of backtrackings are increases. Again, that particular string diagrams also becomes more complicated in order to find out the actual distance. So to avoid the total limitations of the string diagram, this particular travel chart, it plays very important role in order to calculate the movement of the material from one location to the another location. In addition to that, this travel chart is the tabular method. The travel chart is the tabular method which records the quantitative data. The travel chart is the tabular method. So whatever the construction of the travel chart is there, it is indicated by the bottom figure. So this particular method is called as a tabular method. That means whatever the distances are traveled from one location to the another locations, all that particular distances can be represented in the form of tabular form. Therefore, this method will be considered as a tabular method in which the data can be represented in the quantitative form. Quantitative in the sense it is represented in the quantity, maybe 1 meter, 2 meter, 3 meter, 4 meter, like that distances can be represented on that particular chart. For example, the frequency of transportation distance travel by the material and the operator. So which quantitative data we are preserving by using this particular travel charts? That is the frequency of transportation and the distances. Frequency of transportation means from 1 to 2, 2 to 3, 3 to 4, again from 3 to 4, again from 4, again it is coming back to 3, from 3 again it is coming back to 2, from 2 again it is coming back to the 1. So such types of the repetitive transportations or actual distance traveled from 1 to second, that can be recorded by using this particular travel chart in the form of quantitative form. Okay, so in order to represent that particular construction, here you can see in this particular chart, all the departments are listed in the row and the column wise with the same sequence. So in this particular travel charts, so whatever the number of departments are present in the industry, that departments can be represented in the row type and the column type. You can see in the row type here A, B, C, D, E. So all the departments are represented in the row type. Similarly, in the vertical side also, the same departments are represented A, B, C, D, E. So at the top A, B, C, D, E, it can be represented in the row form. Also, it can be represented in the vertical form or it is represented in the column form. That is A, B, C, D. That means once your material or your operator is moving from machine A to machine B or to machine C, from machine E to machine E. So like that, all the distances can be represented by using this particular recorded form. And each interaction box presents the data for the movement from one location to the another location. You can see here, if I will take the example. So here the X is written. Here the X is written. So what that particular X represents is, that means from machine A, your material is moving to the machine number B. From machine A, your material is moving to the machine number B, or from machine B, your material is moving to the machine number A. From or to. Therefore, here at the top here it is written as a from, and here it is written as a to. And in between A and B, there is a X is written. X represents the interaction between this particular point A and point B. Means either your material or operator is coming from this particular point A and it is moving to this particular point B, or either it is representing your material is or operators are coming from this particular point B and it is moving to the point number A. Similarly, here also at the top, again here X is written. So this particular X again represents the movement from B to A or movement from A to B. Similarly, again here another X is written. Again here another X is written. That means your movement is taking place from E to A or A to E, or your movement is taking place from D to A or A to D. But sometimes at the center of that particular rectangle, 2 times X is written. You can see here. 2 times X is written means there is a repetitive movements is taking place either from this B to D or D to B. So whatever the number of movements, whatever the number of repetitive movements are taking place from one department to the another department, that double movement can be represented by the double X. But in some of the other conditions, only one X is written. That means from this department to this department, it is moving, it is represented by only X. If it is moving from another department to the another department, again it is represented by that particular X. That means the X in the one rectangle, single X, it represents the movement taking place from that respective departments. But in some of the rectangle, that means in only one rectangle, 2 times X is written. That means there is a repetitive movements from this particular D to B, or the repetitive movements is taking place from this particular B to D. And at the end, you can see here the addition is taking place. So in the vertical direction, how many times X is written in this particular column A? 2 times, therefore 2 is written. Then in the point B, vertical, X plus X plus X, how many times? 3. Again for C, again 2. Again for D, how much X are there? 4. So here 4 is written. Then in the form of E, how many times X is there? 1, 2, 3. So 3 is written. So like that, vertical addition is also taking place, as well as this particular horizontal addition is also taking place. So horizontally for A, 3 is there. For B, again 4 is there. For C, again 2 is there. For D, again 1 is there. For E, again 4 is there. So at the end, we have made the addition of that particular movements which are taking place from one department to the another department. And from that particular, we can say that for this particular department A, your material is moving 2 times. For this particular department B, in vertical direction, your material or operator is moving 3 times. For this particular material C, or for that particular department C, in vertical direction, it is represented by 2. So whatever the addition we have made, that addition represents number of times your material or your operator moving from department number 1 to the department number 2. So at the end, what we have done the addition of all those particular X which are represented in the vertical direction, or some of the X which are represented in the horizontal direction. And once your movement is completed, at the end we have made the addition of all the X in the horizontal direction, as well as we have made the addition of all the X in the vertical direction, and whatever the number you will get, 2, 3, 4, that number represents number of times visited to that respective department. So if you take the example, in the vertical direction, A, B, C, D, E is represented. At the bottom side, 2, 3, 2, 4, 3. That number represents number of times your material or your operator is moving from one department to that respective department. Similarly, in the horizontal directions also, the numbers are represented like 3, 4, 2, 1, 4. That horizontal distances also represents number of times your material or the operator visited to their respective departments. So through this particular tabular charts, you will get the detailed information about how much distance is traveled by that particular operator, or how much distance is traveled by that particular material from one machine to the another machine. And it can be represented in the tabular form. Therefore, you can easily understand that actual distance traveled by that particular material or the operator. So this is about the travel charts. which will be developed in order to avoid some disadvantages which are present in the string diagram. Therefore, at the bottom side, this last sentence is written. It records the movement of an object in complex situation and it better over the string diagram to its simplicity. So through this particular chart, you can easily get the data from which department to the which department your material is moving, and that movement can be represented by using this particular X at the center of that particular rectangle. That X represents, single X represents the single time movement is taking place from one department to the another department. Double X, it represents the two times your material is moving from one department to the another department, or your operator is moving from one department to the another department. So through this particular tabular method, you can easily understood that the proper movements taking place by the operator, or the proper movement taking place by that particular material from one department to the another department. So whatever the complicated situations are there, all that particular complicated situations are also recorded by using this particular travel chart. So therefore, this travel chart is mostly used in the organizations in order to find the actual distances traveled by the material or the operator. And whatever the limitations are there for the flow diagram, whatever the limitations are there for the string diagram, all those limitations can be eliminated by using this particular travel chart. So this is also one of the third techniques or third recording techniques which is used in order to calculate the distances traveled by the operator or the material from one station to the another station. Okay, so this is about the third techniques, travel charts. Now the next important techniques as a templates. What is mean by the templates? Templates. Here there is no any diagram. In this particular templates, there is no any diagram. There are no any subtypes. Only these templates are used in order to record some of the, or in order to indicate important locations. So in that particular templates, what it indicates, templates means it is one of the cardboard papers or the colored papers. You know about the different types of the sheets are there. Maybe a whiteboard sheet is there, then yellow color sheet is there, blue color sheet is there, then black color sheet is there, then pink color sheets are there. So these are the number of color sheets are available, that all the types of color sheets are called as a templates. All the types of color sheets are called as a templates, and that color sheets are using in order to indicate various facilities or various types of the important devices in your operation process. Therefore, here I have written, unlike to the flow diagram or the string diagram, the templates of cardboard or the color papers are used. So why it is used? The different color templates may be used to indicate the various facilities. For example, the various facilities like machinery, storage rack, benches, equipments, and the buildings. So if I have to indicate number of machineries, maybe if I have to indicate the CNC machine, if I have to indicate the VMC machine, if I have to indicate the drilling machine, if I have to indicate the lathe machine. So all the types of the lathe machines can be indicated by the single color only. For example, I'm using the yellow color. So that yellow color will be applicable for that particular lathe machine only. Now, if I have to indicate the CNC machine, at that time, that CNC machine can be indicated by using the black color sheets only. If I have to indicate all the types of drilling machines, so all the types of drilling machines can be indicated by using the yellow paper only. So these are the standard templates, standard color papers are there. That color papers are used in order to indicate various facilities which are present in that particular organization. So through this particular templates, through this particular colors, you will get the detailed information about if I have to move to the CNC machine. So through that particular color, you can easily understood that. Now this is the color for the CNC machine. I will start moving directly towards the CNC machine. If the yellow color is given for the lathe machine, so I know about the yellow color will be applicable only for the lathe machine. So If I have to move for the lathe machine by observing the color in that particular organization, I will start moving towards that particular lathe machine. So such types of the templates of different colors are used in the organization in order to indicate all the important facilities in the organizations. Also, this template shows the actual floor place utilization. Actual floor place utilization. There are so many floors are there. Maybe at the top floor, maybe your manufacturing section is there. At the bottom floor, maybe your inspection section is there. Again, at the another top floor, your R&D department is there. At another top floor, maybe their packaging is there. If I have to indicate the floors of each and every maybe manufacturing unit is there, inspection unit is there, R&D unit is there, packaging unit is there, then some raw material unit is there. Whatever the number of sections are present, all that particular sections are also represented by using the such types of the templates, or it is called as a colored papers. Therefore, it is having one major advantage is that it is less costly. So as we are using only color papers in order to indicate all the facilities which are present in that particular organization, so these particular methods are very less costly. It can be moved on layout plan, thus providing various layout options. So once your layout is properly designed by using this particular templates, and if I have to move that particular layout, or if I have to shift all that particular templates from one location to the another location, or from one layout to the another layout, it can be easily movable. Because if you think about that particular templates, or if you think about that particular color papers, it can be movable. So we can remove from that particular first layout, and we can implement same templates to indicate for the indication of the another types of the layout. Therefore, it is very less costly, and it can be moved from one layout to the another layout. Also, the duplicate copies can be made. Duplicate copies can be made means, if I have to implement same templates, if I have to implement same colors in the another location, so I can make its duplicate copy as it is, and I can implement as it is all the templates to the another types of layout. Because at one location your manufacturing is going on, at another location also same manufacturing is going on, again at the third location also same manufacturing is going on. So whatever the templates or whatever the colors we have implemented at the first section, same colors, same layout, same templates we can utilize for the second layout as well as for the third layout. Therefore, this template, it can be duplicates, or duplicates copy can be made for the another types of the layout. It is difficult to understand for the non-technical person. It is very important. As we are saying that this color will be applicable for this particular location, this color will be applicable for this particular machine, this color will be applicable for such types of the layout, this color indicates we have to do this particular operation, this color indicates that we have to go in this particular direction. So in order to represent each and every type of movements, in order to represent each and every machine, in order to represent all the types of the machine, the different types of the color patterns are developed. But such types of the color patterns can be readable, or it can be visualized for the technical persons only. So whatever the non-skilled operators are available in the, or those who are operating the machines, so for that particular unskilled operator, it is very difficult to understand that particular templates, because they don't have any idea this yellow color what it indicates, this blue color what it indicates, this white color what it indicates, this black color what it indicates, this pink color what it indicates, because they don't have any idea about importance of the each and every color. Therefore, such types of the templates or the color papers, it is this particular recording techniques, it is very difficult to understand for the non-technical person. So this particular such types of the templates we can use in the various types of the charts also, because in the charts we are showing the different types of the operations, we are showing different types of the inspection, we are showing storage, we are showing the transportation from one location to the another location. So the operation can be represented by using the different color, Inspection can be represented by using the different color. Transportation can be represented by using the different color. Then if any delay is happening, that delay also can be represented by using the different color. So in case of all the types of charts, these templates are also useful in order to indicate the all the types of the operations. Also in case of a string diagram or in case of a flow diagram, department number A we can indicate by using the black color. Department B we can indicate by using the yellow color. Department C we can indicate by the black color. Department D again we can indicate by the yellow color. So in case of a all the types of charts, in all the types of diagrams, all the important facilities which are available in that particular industry, that facilities can be indicated by using the such types of the templates, which are also called as a colored papers. But one major advantage is that it is less costly, but major disadvantage is that it is very difficult to understand for the non-technical persons, because they are unaware about the different types of the color codes which are be given to that respective locations or for the respective machines or for the respective operations. Therefore initially we have to give the such types of the trainings like this particular color is applicable for this operation, this color will be given for the such types of the machine, this color indicates moving from this direction to this direction, this color indicates the delay is happening in the organization. So for each and every color code there is one coding is there. From that particular color we can understood that we have to perform this particular task. So these are the templates. So in this particular templates there is no any other variety, there are no any subtypes, only by using the different types of the colors we have to identify the movements taking place or the number of machines which are indicated in that particular locations. So this is about the templates. And then models. What are the types of models? As we know that the model itself suggests that, for example, if the management or if any senior supervisors are there, if that supervisors has to introduce new technique for the unskilled operator, so it is not possible to give only explanation, it is not possible to give only all the information in the descriptive manner. In order to explain all the such types of the things in advance, if I will prepare the model in advance, if I will prepare the model, through that particular model I can explain all the things in the detail, and by observing that types of models, that's unskilled operators also get the information in very easy manner. For example, 3D elevation, if you take the example of civil engineer, nowadays if I will, if we will give the rough plan to the civil engineer, so what he will do, he will convert that particular rough plan in the actual diagram. Now he's converting that particular plan in the 3D elevation also. That means once your building is ready, how your building is looking like, once your building is ready, how your building is looking like, that 3D elevation is also given to you. Sometimes if you visit to some of the civil engineers at their home some 3D elevations are available in the glass. If he has done some of the big projects, if he has done some of the big projects, so their 3D elevations are available in his home. So through that particular 3D elevations, we can easily get the information about that. Such types of the manufacturing or such types of the buildings can be possible to the made. Or sometimes in our sector also, for example, if we have to give some demonstration to you, at that time what we are doing, we are preparing some of the models by using the thermocols, we are preparing some of the models by using the woods, we are preparing the models by using the some of the card papers, and through this particular model we can explain the some of the things. If I will explain all the concepts without the model, you can understood, no problem. But if the model is available with you, and through this particular model if I will explain the things, then you will get the information immediately. Whatever the important parts are present in that particular model, whatever the power transmission is taking place from one location to the another location, all this particular information you will get from that particular models. Therefore here I have written one sentence, these models can be made by using the woods or the plastic. Plastic, maybe some plastics are available, maybe some thermocols are available, some wooden plates are available. By using that particular woods, by using that particular plastic, first of all, if I will prepare the model, and through this particular model, if I will explain that particular concept to this particular unskilled operators, so through this particular models, that unskilled operators also get the information immediately, and he can also understood that what are the important parts present in that particular models, how the power transmission is taking place from one location to the another location, how that operator has to work on that particular model. So such types of the models are also plays very important role in case of a recording techniques. If you take the example of your tom, in case of a tom, some models are there, maybe that slider crank mechanism is there, then that another model, maybe you can take the example of gyroscopic couple, the model of the gyroscopic couple is available, then another that whatever the number of mechanisms are there for the theory of machine, so in that particular mechanism we are having model in our tom lab. So through this particular model, you can easily understood that how the slider crank mechanism is work, how that particular gyroscopic couple is works. So if I will explain all that particular concept by using the such types of the models, you will get the information immediately. But if I will explain all that particular concepts in the theoretical manner only, you will get the such types of the information, no problem. But if I will explain that particular concept with the help of models, you will get the detailed information about its working condition, about its construction, about its power transmission, about its all the types of application. Therefore, this model is also plays very important role in the method study concept as a recording techniques. So we can prepare that particular model by using the some of the card papers, by using the some of the thermocols, woods, plastic. I can use some of the sheet metals. Okay. Then advantages. What are the advantages? For the layout person, for layout person, it is easy to understood. If I will prepare that particular model, through that particular model, I can understand that particular concept very easily. Overhead facilities can be shown. So whatever the complicated shapes are available, whatever the complicated power transmissions are taking place, all the such types of the complicated situations, I can be represent by using this particular models. Then models can be easily shifted. So models are very small in construction. So we can shift that particular wooden model or the plastic model from one location to the another location. Or we can shift that such types of the models from one department to the another department. They present more and less real situations. They present more and more information you will get from that particular such types of the model, but in real situation, but in less real situation. So some of the conditions are available, so that conditions cannot be shown by that particular types of models, but whatever another important information is there, that information you can get through that particular model. But it is having the two major disadvantages: requires more storage area. Some of the models are available in very small construction, but some of the models are there which are very big in the structure, and if I have to keep that particular models at that time, more storage space is required and they are expensive. So if I have to prepare the model by using the plastic thermocols, so we have to pay some of the extra amount. Maybe plastic is very costly, then wood is also very costly, some of the sheet metals are there, so these are very costly. So for explanation purpose only we are preparing that particular model. That model we are not using in actual application. These models we are not using in actual application. In order to explain the concept only, we are preparing that particular model. Therefore, such types of the model technique, it becomes very expensive. Therefore, in the organization, wherever the requirements of the models are there, for such conditions only we are preparing the special types of the models, and through this particular models we are giving training to the unskilled operator. But in some of the situations the models are not required. Through theoretical explanation only we can give all the types of information for the operators, but wherever it is necessary we can prepare the model. It will be better to understood all the things to that particular operator. Wherever it is not necessary, need not required to prepare the model, you can explain the things only, that operator can be easily understood. Therefore, This model is also one of the recording techniques which is used in the method study concept in order to explain all the types of the constructions, all the types of the operating conditions, all the types of the important elements present in that particular models in the actual application. For example, if I have to explain the lathe machine, it is not possible to take that particular lathe machine in our class. So what I will do, either I will draw that particular diagram of that particular lathe machine, or either I will prepare a one small model of the lathe machine. So through this particular model, I can explain all the things to you, so you can easily understood that. And once your explanation is over, then you can work on that particular lathe machine, and on that working also, you can easily understood that how the machine is working, what are the important parts, how the power transmission is taking place from one location to the another location. So such types of the models are used for the present representation purpose. The use of this particular models is mostly used in the civil applications. Most of the civil engineers, they are instead of giving the 2D drawings only, now they are giving the 3D diagrams also, how your building will be look like. Once your construction is over, your building will be look like this. So like that 3D diagram is also given to you as a model. Also, some of the big construction or some of the big sites are there which will be performed that particular civil engineer. So he has prepared some of the 3D models and he is kept at his home. So through this particular model also, you can get the detailed information about which types of the buildings he has constructed, which types of the projects he has completed. So like that information you will get through this particular model. So these models are having some of the advantages also, some of the disadvantages also. That advantages are represented in the form of you will get the detailed information. All the important devices can be indicated through this particular model. That models can be shifted from one location to the another location. You will get all the detailed information. But whatever the real situations are there, whatever the real power transmission will be taking place, it will not be visible in that particular model. And what are the major two disadvantages? More space is required to store it, and it becomes more expensive. As your material is very costly, so this particular method becomes more expensive. So this is also one of the recording techniques which is used in the industry for the demonstration purpose. So the templates and the models, they are having only some of the explanation. They are not having any subtypes, they are not having any another types of the diagrams. There is a only theoretical concept where the templates are used and where the models are used, and what is the use of that particular templates and what is the use of that particular models. So these are the some of the recording techniques which are used in the method study. So with this, today we will stop here. The remaining part we will see in the next lecture.